Tonight we're going to be taking a look back at solving equations, but this time with the idea of functions to support us. So we're going to take a look at this first equation. Our quantity x is being increased by 3, then cubed, then having 4 taken away from it, and we're looking for that quantity value for x to be equal to 7, which is a separate value. So you're looking at equations horizontally. You can actually break down equations and write them vertically as well. So again, I'm going to start with my first quantity, which is unknown. It's an x value. And those operations that are being applied are actually, you can think of them as little baby functions. So my first baby function is that increase of 3 to my original x value. Then the second function that's happening is that it's being raised to the power of 3, or it's being cubed. And finally, after it's originally added to 3 and then cubed, everything all together, 4 is being taken away. It's the third little baby function that builds into the equation. And it's being related to this value of 7, which is another quantity. So we're taking this unknown quantity and relating it to a value on the other side of the equal sign. So solving equations, we're looking, and our goal is to find that value of that unknown quantity. So we actually work our way back up through the little baby functions by applying their inverse functions. So taking a look at the very first thing that we approach is this subtracting 4, or taking away 4, which is our function. So how do you get rid of a function? Well, you compose it with its inverse. So the inverse of subtracting 4, or taking away 4, is adding 4. So instead of taking away 4 positives, I'm going to add 4 positives, and that's going to create 4 sets of 0 pairs. Looking at the second, I'm going to see that a function that's being raised to the power of 3, I can actually raise it to the 1/3 power. That 3 and that 1/3, using the law of exponents, actually creates the multiplicative identity in the exponent, and anything raised to the power of 1 is itself. And finally, looking at that original function, which happens to be the last one that we build upon together, I can see that similarly to the first thing that we worked with, the inverse of adding 3 positives would be taking away 3 positives. So taking a function and its inverse, composing them together, creates the identity. So in this case, adding 3 positives, taking 3 positives away, I'm going to be creating 3 sets of 0 pairs. Building these together, I can see that I'm going to have 11, which is the value, plus that original 4, which was the inverse of that first function. Then I'm going to raise that entire value to the 1/3 power, and then I'm going to take 3 away. So my value for x is the number, it's 11, raised to the 1/3 power, subtracted by 3. So let's check our work. We're going to start with the original equation and our solution to that equation. And we're going to plug in our solution for wherever our unknown quantity is, x. So I'm going to rewrite everything in the equation. Just like our function composition, I'm going to substitute this value into wherever I see my x. And I can see almost immediately that within those parentheses, I have a 0 pair. Taking away 3 and adding 3 are inverses of each other. They create the additive inverse, which is 0, the do nothing. So I can rewrite my entire problem. 11 raised to the 1/3 power, we're all raised to the 3rd power, taking away 4 is equal to 7. The 1/3 power raised to the third power is the power of a power law of exponents rule. Anything raised to the 1 power, which is going to happen when you have 1/3 and 3, is itself. So 11 raised to itself is 11. Take away 4 is equal to 7. And we can see that it's true. 7 does equal 7. So in fact, our solution, x is equal to the quantity 11 raised to the 1/3 power, take away 3, is the solution to our equation.